All right, so the notes for 13.3b have the same title as yesterday's notes did. So it says solving absolute value equations, but it's part 2. So the equations that we solved today are going to be a little bit more detailed or a little bit more complex than the equations that we solved in the previous day's lesson in 13.3a. The essential question for today says, how do I solve absolute value equations when the absolute value bars are not already isolated? You want to remember that isolated means right here. Isolated means that they are by themselves. And so in the notes for today, we're going to have to do a step or two first before we can solve the question. The notes for today, you'll be excited to hear this, are only on the front of this paper. So there's no back to today's notes. We're going to do example number 1. I guess it's the only example, so you could just write example instead of example number 1. And the directions for the notes for today say solve. So we're going to do an A and a B, a C and a D, write a takeaway, and that's all the examples that we're going to do in the notes for today. Make sure that you're very careful to listen to the description in the notes today so that you don't just get stuck in the habit of writing down the notes and not listening to the verbal part of the instruction. The things that we talk about today in the notes are going to be important because you might get fooled into thinking that the notes for today are exactly the same as the notes were in the previous day's lesson, and that's not true. They're a lot alike, but they're actually a little bit different, and so you want to make sure that you're careful about that. All right, let's see. So for example number 1a, the directions say solve, and the equation that we're going to solve for this one says the absolute value of x minus 6 is equal to 1. So at first glance, this looks like it's exactly the same as what we did yesterday. It has bars, it has an equal sign, it has a number. But what's actually true about this equation is that it's a little bit different. This says if I take the distance that something is away from 0, and if I subtract 6 from it, it's going to give me 1 out as my answer. So there are 2 numbers that would produce a correct solution for this equation. But what's tricky is you are not going to start by splitting this off and making 2 because the absolute value bars are not isolated yet. They're not by themselves yet. If you look at your equation on your paper, there's the 6 over with the x that's making it not be all by itself. So what I need to do on this question before I split it off and make my 2 is I need to add the 6 to both sides to get the absolute value bars all by themselves. And now this looks like what I did yesterday. So anytime you have a number in front, behind, or under the absolute value bars, you're always going to take a step to get the bars all by themselves before you consider your 2 solutions to the question. So for this one, x could be positive 7 away from 0 in the positive direction, or x could be negative 7. So it could be 7 away from 0 in the negative direction. You could write your answer like this. You could write your answer with a comma in the middle, or remember for these, a lot of people will write their answer as plus or minus 7, so they'll use that symbol instead to write their answer to the question. If I plugged a positive 7 in right here, 7, the absolute value of 7 is 7, and then 7 take away 6 gives me 1. If I plugged the negative 7 in here, the absolute value of negative 7 is also positive 7, and then 7 take away 6 is equal to 1. So you are still getting 2 solutions, but the part in red is the part that you had to do first. So this is different than the notes that we did in 13.3a, because in 13.3a you didn't have to do the red part, you were just ready to split them off and make their own. And so keeping your eye on this and remembering what it is that you're supposed to be doing can actually be really tricky because the equations look a lot alike. And so you're going to have to be careful that you don't turn your brain off when you're doing this. You're going to want to make sure that you stay really clear and really aware of what it is that you're solving. So in the second example, it says 2 times the absolute value of x plus 3 is equal to 14. So this says I'm going to take some number and add 3. I'm going to calculate the distance that is away from 0, and then when I double it, it's going to be 14 away from 0. So on this question, the plus 3 is on the inside of the bars. So I'm not going to do anything with the plus 3 right now. But if you notice, the 2 is on the outside. So I can get rid of that 2 a couple different ways, but the easiest way for most people to get rid of it is they would divide both sides by 2. Because when you do both sides divided by 2, these 2's over here will cross off, and what you'll be left over with is the absolute value of x plus 3 is equal to 7. What I just wrote down right here after I did the divided by 2, this looks like what we did yesterday. And so that one is ready to split the 2, drop the bars, and solve. But it wasn't ready when I started because I had that 2 out front. So you want to make sure that you're taking that first step to isolate or get alone the absolute value bars before you do your 2 and you split them off to make your 2 equations. So just a little review from yesterday. This plus sign on the inside here is not going to change. So I'm going to say that x plus 3 can be 7 away from x in the positive direction. And then I'm going to say that x plus 3 can be 7 away from x in the negative direction. So that's how I create my 2. This 7's positive, and then this 7 over here is negative. On this side, I'll get x equals 4. And then on this side, I'll get x equals negative 10. So I'm still getting 2 answers to the question. I could put a box around this one and put a box around this one. I could write them with a comma. I just can't write them like this because it's not plus or minus of the same number. One of them's a 4 and one of them's a 10. But it's okay to box your answers separately for these, or you can box them together. So either way, it's fine. This one had 2 solutions. This one had 2 solutions. So there's 2 numbers that I can plug in up here back to the original equation, not the part with red, that would make this equation work. 4 plus 3 is 7. The absolute value of 7 is 7, and then 7 times 2 is 14. When I plug in the negative 10 plus 3 is negative 7. Negative 7, when you do the absolute value, is positive 7, and then positive 7 times 2 gives me 14. So these are the only 2 numbers that I can plug in to get an answer to this question. All right. We're going to use the rest of the space on the notes to do example C and example D, and then we're done with the notes for today so that you can get on your own and start practicing these types of questions. Solving absolute value equations when you learn it isn't that hard the day of for most people, but what's tricky is when you see these kinds of questions mixed in with other kinds of questions. That's when it gets to be a little bit tricky. All right, so let's see. For example C, it says the absolute value of x minus 3 plus 8 is equal to 7. The absolute value of x minus 3 plus 8 is equal to 7. And so this one also needs an adjustment before we can start and split it off and make our 2. So on this one, I'm going to have to minus the 8 from both sides before I start because I need to get the absolute value bars all by themselves. It's going to turn this equation into the absolute value of x minus 3. Notice that I haven't dropped the bars yet, is equal to negative 1. And so you guys, this is a tricky place for most students because a lot of people, you're just in the flow of solving. And so you're ready to split it off, make the 2, have one be positive, have one be negative. But I want you to stop before you do that and circle the negative sign that's right here. And you have to remember the thing that we talked about yesterday. Some number, when you take away 3 and you take it out of the absolute value bars, it can never come out of the absolute value bars as a negative. And so we're going to make a note on the paper here just in a second, but I want you to write down first the answer to the question. This equation has no solution. And so this question doesn't have an answer. There's no number that you can plug in here and take 3 away and get the absolute value of it and add 8 to it and then have the answer be 7. Because this piece can never be negative, you can never add 8 to something positive and have it go down to 7. Just make a note on your papers right here like we did yesterday that says that absolute value can never come out of the bars and be equal to a negative number. Absolute value can never come out of the bars and be equal to a negative number. And so this is how I know on this question that it's going to have no solution. All right. So question D is going to be the last example that we do in the notes for today. It says 2 times the absolute value of 2x plus 3 is equal to, plus 5 is equal to 23. 2 times the absolute value of 2x plus 3 plus 5 is equal to 23. And so this example has the most steps out of all the ones we've done today because it has a number out front and it has a number in the back. You're not going to do anything with the 2 numbers that are on the inside because you'll take care of those when you split it off to make your 2 equations. But I'm going to have to fix the 5 and I'm going to have to fix the 2. And so I'll start by doing that. So I'll begin and I'll minus the 5 from both sides. So that would give me 2 times the absolute value of 2x plus 3 is equal to 23 take away 5 is 18. And then I'm still not quite ready to split it off and get my 2 because I still have this 2 out front right here. So right here, I'll divide both sides by 2. And that'll give me the absolute value of 2x plus 3 is equal to 9. You know that you are ready to split it off and make your 2 equations when you have the absolute value bars all by themselves. There's nothing in front of them, there's nothing behind them, there's nothing underneath them. So it's just the numbers that are here on the inside of the absolute value bars. And so that's how you know that you're ready to do this and make your one equation, and do this and make your other equation. This might be a good place to stop the video and work ahead and see if you can get the 2 answers to this question. You're going to get positive 3 as one of your answers, and you're going to get negative 6 as your other answer. So if you do the question and if you get those 2, you don't need to rewind it to re-listen to the explanation for the solving because it means that you're all set. So here we go. So the inside can be equal to the positive of this number, and then the inside can be equal to the negative of this number. The only thing that changes between these 2 equations is the positive 9 and the negative 9. And so when I go through and I solve this to find my 2 equations, I'm going to subtract the 3's and divide the 2's. And so I'm going to get positive 3 as one of my answers, and I'm going to get negative 6 as my other answer. And so those are the 2 numbers, the 2 solutions that would work as an answer to this original question that's typed on my paper. So before we wrap up today, remember tonight at home you're going to come up with 2 study questions that kind of encapsulate this. Make sure you make one of the study questions be something about how today's notes was different than the notes that we did the day before. But today before we wrap up, we're going to write down our takeaway together. So our 1 to 2 sentence summary for this, I think that a good takeaway for this would include at least 1 sentence about how these notes are different than yesterday's notes. So about how the red part up here is different. And so a good summary for this page would have something to do with what you need to do first before you can solve it. So for mine, I wrote for my takeaway, I said you must isolate the absolute value bars and remember the word isolate means that you have to get them by themselves. So it says you must isolate the absolute value bars on one side of the equation and when we did it, our one side of the equation was on the left, but you could do it on the right as well. It's just more traditionally done on the left. So you must isolate the absolute value bars on one side of the equation before proceeding or continuing with splitting the equation into 2 possible outcomes and solving to find the 2 solutions. And again, on my summary, I put the word 2 in parentheses because sometimes you can have 2 solutions, but it's also possible that you could have 1 solution or no solution. And you'll see examples of each of those as we move forward with the notes for this section.